Assalamu alaikum students. Today I am here to explain a new topic for you, that is isotopes. Isotopes is also in atomic structure, and today by the end of this lesson you will learn that what isotopes are and what type of questions that are coming to exams related to this topic. We will also discuss it. So what isotopes actually are? We are saying that isotopes are atoms of the same element of the same element having same number of protons and electrons, but different number of neutrons, So the isotopes are atoms of the same element having same number of protons and electrons as well, but different number of neutrons. They only differ in neutrons. We are considering over here the of example of bromine. So bromine, its atomic number is 35 and one of its isotope has atomic mass 79. Secondly, we have its another isotope which is 81. So we can call them as bromine 81 by its atomic mass and bromine 79. Now talking about its number of protons and electrons and neutrons that you had already calculated in your previous lessons. So talking about its protons are equal to its atomic number, so 35. Number of electrons 35 as well, because you are familiar that an atom is electrically neutral. So electrically neutral particle have the same number of protons and same number of electrons. Talking about their neutrons, so the neutrons are atomic mass minus atomic number 79 minus 35. Answer will be 9 minus 5 4 and 7 minus 3 4. Now for bromine 81, protons are 35, electrons are 35 and neutrons are 81 minus 35, and here the answer will be 46. Over here we have found that according to the definition, same number of protons, same number of electrons, but different number of neutrons. Here the neutrons are 44 and here the neutrons are 46. Now we can also modify our definition in this form by looking at the symbols of bromine. Atomic number is 35, but atomic mass over here is 79 and over here atomic mass is 81. Our nucleon number is different but proton number is same. So we can modify our definition of isotopes, that isotopes are atoms of the same element with the same atomic number but different atomic mass or nucleon number. We can write in bracket nucleon number is different. Mostly the elements exist means most of the elements commonly occur in isotopes. Most of the elements commonly occur in isotopes. If they are commonly occurring in isotopes, so each isotope has its percentage abundance, and due to that percentage abundance, each isotope has its percentage abundance due to this the atomic mass changed into relative atomic mass. In simple form, we can say that it is the average mass of all the isotopes of an element, all the isotopes of an element. Because if we are considering for bromine, so bromine has the two isotopes. One has the atomic mass 81, one has the atomic mass 79. So here is the confusion that which atomic mass we will use in our calculations or in the periodic table. While in the periodic table its atomic mass is given, that is 35 into 80. That 80 is actually the relative atomic mass, which is the average of these 79 and 81, and how it can be calculated. For example, uh, we are taking another example that is of chlorine. So chlorine also exists in two isotopes. Chlorine exists naturally in two isotopes that are chlorine 35, which is chlorine 17 atomic number and 35 its atomic mass, and chlorine 37 and its symbol is chlorine 17 its atomic number and 37 its atomic mass. Its percentage abundance for chlorine 35 is 75%, while for chlorine 37 it is 25% naturally. So relative atomic mass can be calculated in this way. Relative atomic mass, which is denoted by AR, and it will be equals to percentage abundance multiplied by atomic mass of the first isotope plus percentage abundance of the second isotope multiplied by its atomic mass. So I had mentioned over here A1, the atomic mass of the first isotope, and the atomic mass of the second isotope. In order to change the percentage into fraction, we have to divide it by 100. So the percentage abundance of the first isotope is 75, its atomic mass is 35, plus percentage abundance of the second isotope is 25, and multiplied by its atomic mass is 37 divided by 100. When we are going to multiply these two figures plus the product of these two figures, we will get the answer 3550 divided by 100. So 3550 divided by 100, our answer will be 35.5, which is the relative atomic mass of chlorine that is given in the periodic table. It doesn't mean that chlorine has half a proton or half a neutron, but it is because of its isotopic abundance. Now, the next thing that we have to discuss over here, not all the elements exist in isotopes, or not all the elements are naturally occurring in the form of the isotopes. Some of the elements are pure elements, don't have isotopes, and one of the example is few elements don't have isotopes. For example, we can get the example of fluorine over here, which is fluorine is 9 into 19. It means how many protons it has. Protons are 9. How many electrons? 9. And how many neutrons are here? 19 minus 9 equals to 10. It means all the atoms of fluorine has all the atoms of fluorine have 9 protons, 9 electrons, and 10 neutrons. There isn't any difference of neutrons in fluorine atoms. So from this we can get another information that isotopes have same chemical properties isotopes have same chemical properties but slightly differ in physical properties. Slightly differ in physical properties. So what is meant by this? Like they have the same chemical properties and different physical properties. We can get the example of hydrogen isotopes over here. So hydrogen has the first isotope hydrogen 1 and the second isotope is hydrogen 2. So same number of protons or same proton number but different nucleon number or different atomic mass. Over here we can say that they have the same chemical properties because chemical properties or chemical reactions involve only the electrons, because chemical reactions involve only the electrons. So all the isotopes have the same number of electrons. That's why we can say that they have the similar chemical properties. Now, talking about these two isotopes, hydrogen 1 and hydrogen 2. So hydrogen 1 has a slightly lower boiling point and density than hydrogen 2. Hydrogen 2, this is hydrogen 1, this is hydrogen 2, and over here we can say that hydrogen 1 has slightly low boiling point and density than hydrogen 2, and it is because of the difference of atomic mass. Over here its atomic mass is 1 and its atomic mass is 2. That's why we are observing this difference in physical properties that is in the form of boiling point and in the form of density. Now we will discuss some of the question that is coming in the exam, and that question is related to the isotopes. Question is, in a sample of 100 atoms of potassium, there are 94 atoms of potassium 39 and 6 atoms of potassium 41. Explain why these two forms of potassium are isotopes. So it is clear from these two symbols, if we are discussing the answer of A part, over here we have to look for the information that is given in the form of the isotopes for potassium. So over here protons are 19 and we have electrons are 19. For potassium 41, protons are 19 as well and electrons are 19 as well. Talking about neutrons, 39 minus 19, answer will be 20, and over here the neutrons are 41 minus 19 and answer will be 22. So it is clear from this calculation that these two isotopes have the same number of protons and same number of electrons but different number of neutrons. So we can easily define that. Why these two forms of potassium are isotopes? Because they have same number of protons and electrons but different number of neutrons. Different number of neutrons. That's why they are isotopes. Now, talking about the B part. Find the total mass of 100 atoms of potassium. Total mass of 100 atoms of potassium. Over here, 94 atoms of potassium 39. We have the 94 atoms of potassium 39 and 6 atoms of potassium 41. It means that each atom has 41 atomic mass and over here each atom has 39 atomic mass. So total mass of potassium sample is 94 times 39 plus 6 times 41. When we are going to find their product and adding their answers, we will get our answer 3912. And what else we have to find? Find the average mass of one atom, which is relative atomic mass. So in order to find the relative atomic mass, we have to find first the percentage abundance. So we can calculate the percentage in the form how many atoms? 94. And what are the total atoms? 100 atoms. So what would be the percentage of potassium 39? So we can write over here the percentage of potassium 39, and it would be 94 atoms divided by 100 multiplied by 100%, so we can get 94%. Similarly, the percentage abundance of potassium 41 will be 6% according to this. So relative atomic mass is percentage abundance of the first isotope multiplied by its atomic mass plus percentage abundance of the second isotope multiplied by its atomic mass divided by 100. If we will consider the above total mass of the potassium sample, so our this one is similar to the total mass that we had earlier calculated, and this is 3912 divided by 100. So our answer will be 39.12, which we can round approximately 39, and that is the atomic mass of potassium atom that is given in the periodic table. So this was related to the isotopes from the atomic structure, and I hope you will like this teaching of isotopes, and will meet you in the next video with the next topic, inshallah.